are we doing? We'll wait for like a minute to start this. Alright. How's it going? Looks like we will start. So if you have your packet, flip to this page. This is the general sequence packet. You guys find this? Right. This stuff is going to be a little different from all the other sequences. Before we start, do we have any questions on like any of the homework? I can go over that really quickly. If you want to go into detail, then you can, email me in office hour. But do we have any quick questions about geometric arithmetic sequences? This is a good time to think about that, because the next part is going to be a little different. We're talking about number 2 in the packet or number 2 in the worksheet. Packet, number 2 on the packet on the previous page, like this page, this one. This one. This one, number 2. Okay, so So for this one, you kind of want to look at, because at first, if you look at it, first of all, is it geometric or arithmetic? How could we check? If it's arithmetic, then you have to add the same number, right? So if it's arithmetic, here it's -1, and then here it's not -1, it's like -1/9 or something. So it's not arithmetic. And it's not geometric either, because this to this is half, this to this is not half, right? Okay, so it's neither. Now, since it's neither, we kind of want to look at it, because some of them are fraction, some of them are not fraction, right? If you look at it. So we kind of want to make them all fractions to start, to see if we can see a pattern. Okay. So I'm going to start with this. So this is like 2 over 1, right? 1, I'll leave it for now. 8 over 9. 32 over 25, right? And then you have these, right? So if you look at 2, 8, 32, what would you think about? How would this go? 2, and then blank, 8, blank, 32. What do you think about? What pattern do you see? Times 4, right? But there's a blank in the middle. So if I were to fill in these blanks, what would they be? What would these blanks be if you were have to complete this sequence? Just the top. Times 2, right? Like if you do 2, 4, you multiply by 4, right? Multiply by 4. So this is, if you want to go in between, you kind of need a times 2 in the middle, right? Times 2, times 2. So this will be 16. Does that make sense? So 2, 4, 8, 16, 32. Okay. So then, because these have values, right? If you look at it, 1, 4, right? So if you want to be 1, this has to be 4 over 4, and this has to be 16 over 16, right? Because it wants to be 1. Right? 1 here, 1 here. Okay? Alright? So then, let's look at the top. 2, 4, 8, 16, 32. That's what? 2 to the n, right? That's geometric. What about the denominator? 1, 4, 9, 16, 25. What would you think about? What is this? 1, 4, 9, 16, 25. Any takers? And square, right? And square. Right? Then that's it. That's the nth term. Okay? Let's check if it works. If n is 1, that means it's the first term. Right? 2 to the 1 over 1 squared, that's 2, right? 2 over 1. Right? And then the second one's term number 2. 2 squared is 4. 2 squared is 4. So 4 over 4. Okay? This is a special one. The special ones are always the most interesting one because it's like you need to actually think about a lot of things. How are we doing? Does that make sense, Miles? Yeah, great. Any other ones, quick ones before we start today's stuff? No? Okay. So let's go look at this part. This is a general sequence. So today we're going to talk about the sequence that are like neither arithmetic and geometric, kind of like what we had just now. But these are a very specific kind. They are a square kind. Okay, I'm going to talk about why it's called square kind in a bit. But that's basically what they are. Okay? So let's talk about this. So if you look at this, let me give you a couple of seconds, or a couple of minutes. Look at this. What pattern do you see? What pattern do you see? Okay, what pattern do you see? This is essential before we start looking at like the actual problem, so that way when I'm explaining it, it would make sense. Okay? So take a look first. How do I look at this? What do you see as patterns? So I'm gonna make a table, okay? Look at the differences, right? Oh, okay, so what is the differences? How are the differences related? So this is term number. This is the actual term, right? Tn, okay? So this is 1. The first term is 1. The second term is 3. The third term is 6. The fourth term is 10. The fifth term is 15, right? Really good. Oops, sorry. So Sahana said, look at the differences. Difference is plus 2, right? What is this? Plus 3, plus 4, plus 5. Now, seems like they are adding the difference in a plus 1 kind of manner, right? So you're going to do it twice, correct? Like that. Okay. Now let's look at what kind of equations we can kind of get them into. Okay, so let's look at, so the strategy we have here is the following. Okay, so we're gonna get this. So the first term is 1 times 1, right? And this one, 3 to 6 is what? 3 times 6. 3 times 2. Right? 6 is 3 times 2. And then 5 is 5 times 3. Do you see a pattern here? 1, 3, 5, 1, 2, 3. So we kind of skip a term first and see how they look. Okay? Now, the term number times 1 is this, term number times 2 is this, term number times 3 is this. But there are terms in between, right? You see that? So let's try to fill this out, okay? So that way we can find the differences. Now, because what is the difference in the number? This is 2, right? I'm skipping 2, right? So if you look at this, wouldn't this be, if I want to go in between them, okay? What is in between 1 and 2? What's in between 1 and 2? What's the midpoint? What is the midpoint between 1 and 2? Yeah. What's the midpoint? Isn't it 3 halves? 1 and a half? Right? 3 halves. And the middle between these two is 5 halves, right? Let's see if it makes sense. I mean, let's see if it matches. 2 times 3 halves, isn't that 3? 3 times 5 halves, isn't that 10? Because 3 times, 3 times 5 halves. Oh, 4 times 5 halves. Why did I put 4? 5. 4 times 5 halves. Because it's 1, 2, 3, 4, 5, right? Okay. So then that way, I match the sequence. So what is the pattern here? Obviously, if you look at this is 1, 2, 3, 4, 5. I'm multiplying these, which is n, right? This is the number, term number, times what? This is 1, 3 halves, 2, 5 halves, 3. Hard to see a pattern here. But what if I modify this? Okay, I'm going to modify this into common denominator because I want to see what it looks like. So 1 is 2 over 2, right? 2 is what? 4 over 2. 3 is 6 over 2. Now do you see a pattern? 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2. So what is that? Isn't that something over 2? But that something is 2 over 2 to start, not 1 over 2 to start. So we do m plus 1 over 2 times n. And that is your general term. Tn equals this. Okay? This is one of the hardest thing to think about sometimes because it's a little bit confusing on how the pattern came out to be. Okay? So we are going to analyze it a bit more. Okay? We're going to practice a few times. Any questions? All right, let's move on to the next one to see the second part. Okay? We'll do another one. So this is another one to look at. It's very similar to the previous one. Let's make a table again. All right. So I'm gonna do, once again, this is n is term number, Tn is your actual term. We'll start 1, 2, 3, 4, 5, right? 5 terms. And then you have 2, 9, 20, 35, 54. Okay? So let's see how these change. Right? How these change. Wait. Oh, how did I get n plus 1 over here? So it's n plus 1 because if you look at where it starts with 2 over 2, right? The first one is 2 over 2, not 1 over 2. So when your n wants to be 1, it has to be 1 times 2 over 2, right? Not 1 times 1 over 2. So it has to be n plus 1 over 2. Because they're all over 2, right? But your starting point is 2 over 2, not 1 over 2. So it has to be n plus 1. So this is the next one. And the next one will be adding 1 again, then add 1 again, and add 1 again, and add 1 again. So instead of n over 2, it's n plus 1 over 2. It's to match the index, basically. Okay? Does that make sense? Okay. So all right. So let's write out the pattern first. The pattern should be easier to write versus the actual equation, right? Because the actual equation is a little hard. So this is what? A plus 7, a plus 11, a plus 15, a plus 19. Okay. All right. Next one, right? So then you would do next part is plus 4 plus 4 plus 4, right? So that's 2 layers again, right? So for 2 layers, right? The one I like to use normally is I just make one of them to be the n first, so that way I don't have to, look at further. So you can look at it any way you want. After you simplify, it should look the same. So you know that it's kind of gonna be a multiplication. Okay, so let's look at what it looks like at first, because the way we look at it, didn't we just do like you want to look at the pattern, right? So the difference right now is, how about you look at it first? You look at it first, because I want to see how much you can get from this. Take a look. Any good ones that I want to share? You have any good ideas? Alright, so I think the biggest problem here is that we have problems starting to get some patterns, right? So the key point here is you want to try, like, if you try, right? If you try, like, start with 1, 2, 3, 4, 5, then you realize that there's no real pattern to this. If you look at it here, 1, 2, 3, 4, 5, right? If you do like this, times, this first one you want to be 2, right? So that's times 2. The next one is to 9, so that's 2 over 9, or 9 over 2. The third one is 20 over 3, and the fourth one is 35 over 4. And then you realize that 54 over 5, and none of them give you any sort of pattern, right? If you look at it, the right side, this is a fail, right? Fail. Okay, so our way to fix this problem is to change the index. Okay, change index. Okay, how do we change index? So instead of starting with 1, let's start with 2 instead. Or try. Instead of saying try, we say let's start, we say try with 2. Okay, we're going to try with 2. So if we try with 2, take a look, then all this, right, 2, 9, 20, 35, so 1, 2, 3, 4, 5 will become 2, 3, 4, 5, 6. Okay, so I change that index. If I change that, what then becomes what I multiply by to get these? Well, how did I get 2 from 2? I multiply by 1, right? And then 3 to 9, I multiply by 3. And then 4 to 20, I multiply by 5. 5 to 35, I multiply by 7. And then 6 to 54, I multiply by 9. Do you see a pattern? What is the pattern here? Isn't the left side, since you start with 1, you start with 2, you have to do n plus 1 times 1, 3, 5, 7, 9. That is called odd numbers. To do odd numbers, there are 2 ways to do it. One is called 2n plus 1. One is 2n minus 1. In this case, it's 2n minus 1 because the first one, when you plug in 1, it must be 1. Right? If you try it times 2, 2 times 2 is 4, minus 1 is 3. Okay? That's your Tn. I know at this time you're probably still like, how? What? Hello? How did you do that? That's okay. Let's look at one more. Are we okay? There's no response. I can't tell if you guys are confused, kind of hard, or this is so easy. I really get this. What? From level from 1 to 10, how bad? Oh, Shreya says we're good. How easy, how hard? 1 to 10. Give me a number. Six. 6 means kind of hard. Okay. So let's. If 10 is hard, you're at 5. 2, 5. Okay. So let's look at the next one. 4 out of 5. Or 4 or 5. So that's like medium then, right? Okay. Not bad. 5's not bad. Okay. So 0 to 5, 9, 4. Okay, so I'm going to write it again. So we're going to look for another pattern. So this method works for squares only. Okay, squares meaning like when you multiply out. See, if you multiply this out, you'll get a quadratic. It's called square function because it makes a rectangle when you multiply out. Okay. So this one, same thing. 1, 2, 3, 4, 5, right? And this is 0 to 5, 9, 14. Kind of like that. Okay. All right. So let's look at the difference. Difference is plus 2, plus 3, plus 4, plus 5. And you're like, oh, there's a pattern. I'm adding 1 each time, right, with my difference. Okay. So I know I'm going to use very similar method to what we just did previously. Now, to get a 0, okay, to get a 0 from multiplication, how can I get a 0 from multiplication? How do I get 0 from multiplication? Has to multiply by 0, right? So I at least know one of the index has to be 0. Now, since we want to try 0, okay, because of this, C0, try 0. Okay? Why? Because there's only one way to get 0. You have to multiply by 0, right? Okay. So then the next part, since I know I'm going to start with 0, let's just go down the road then. Let's try see if that works. Okay, 0, 1, 2, 3, 4. Right? Kind of like that. And then let's see. So the right side here is not obvious what I need to do. But the next one, to get 2, I must multiply by 2. To get 5 from 2, I multiply by 2.5, where I can say it's 5 over 2. To get 9 from 3, I multiply by 3. To get 14 from 4, I multiply by 14 over 4, right? Let's see if we can see a pattern. Can we do common denominator here? I think over 2 is fine, because this is what, 7 over 2, right? So if I convert everything to over 2, then this will be 4 over 2. This will be 5 over 2. This will be 6 over 2. You see a pattern? 4 over 2, 5 over 2, 6 over 2, 7 over 2. Then what would this one be? What would this one be? The first one. Right, this is 7 over 2, 6 over 2, 5 over 2, 4 over 2. This has to be what? 3 over 2, right? Has to be 3 over 2. Okay? Very nice. So, now the pattern. Now, originally your index started with 1. Now you start with 0, so when you modify your n, your Tn has to be n what? Should it be plus 1 or minus 1 to start? Compared to your real index n. Minus 1, right? Minus 1 here, right? Subtract 1 to get the first index. Then the second pattern, you see this over 2 all the way, right? So there has to be an over 2 here. Okay? And then it starts with 3, then 4, then 5, then 6, then 7. They're going plus 1 each time, so you know it has to be n, not plus 3, because you remember your n starts with 1, right? This is n equals 1. Because you already did n minus 1 here. So it's not n plus 3, but plus 2. Okay, but good try. Plus 2. See if it matches. You plug in 2, you get 2 minus 1, that's 1. 2 plus 2 is 4, right? 4 over 2. So checking if the index works. That's fine. It's a good try. But we get it, right? It's like, once you figure out the pattern, you really want to match up the number. Yeah. And plus 1, plus 2. So whichever difference you're adding, like plus 1, then that's how many n's you have. So for example, if it's plus 2 each time, then it's 2n plus something. If it's plus 3 something, then it's 3n plus something. Okay? That's because whatever you're adding, that's a linear slope, right? So like, this is plus 1 each time, so it's 1n plus something. Okay, the plus something part is where you start, right? If you start with 3, that means the first one has to be 1 plus 2, right? Okay. Okay. So that's pretty much what I want to teach you today. Stuff like this takes practice, okay? Your homework this week, I think I already posted on Google Classroom. I haven't posted on School, but on Google Classroom you should already have the assignment. It's basically the next 3 pages, okay? And you also take first to 4th page. So they're all the same thing if you look at it. All right, you have this page, and then this page, and then some of them are not square sequence, okay? These are just general. Sometimes it's arithmetic, sometimes it's geometric, sometimes it's this one, okay? So if it's this one, then you use the method that we just talked about. If it's not, then you would try to do something else to it. Okay, sometimes it is, sometimes it's not. Does that make sense? Okay? Any quick questions? So let's take attendance first, okay? Wait. Now multiple files is okay. In Google Classroom, you can submit in separate pictures. That's all fine. Like I can click on individual one. As long as you can upload them, I can see them. Okay? So if you're here, press here so that we can look at yeah. Let me click on the attendance part. So yeah, 26 people. Let's see. is not Somani here. About oh, hi. Good. I don't see Matthew's son. Is Matthew's son here? Matthew's son? No Matthew's son today? Matthew is not here, I think. Or maybe I'm just wrong. I don't see his name either. Anyway, Matthew, if you're watching, send me an email about what you watched. Okay? Before 3:45 today. Okay? Alright, any other questions before we close? You can do your homework then. Alright, the next 3 pages, well, first 4 pages of general sequence. Okay? Alright. Goodbye. Have a good rest of your day, I guess, or week. Oh, you're here? Nice. No problem.